Welcome everybody to example 2 of using the ratio and root test for infinite series. So once again, we're asked to determine whether a series is going to converge absolutely, diverge, or whether the ratio test gives us any information at all. And so again, just a quick review of what the ratio test says. So for the ratio test, we look at the ratio of the limit of the ratio of consecutive terms. So we look at a sub n plus 1 over a sub n, and the limit as n goes off to infinity. That's going to give us some value rho. Now, if rho is in between 0 and 1, then we know that the series is going to converge absolutely. If rho is bigger than 1 or even infinity, we know that the series is going to diverge. If rho is equal to 1, then the series is inconclusive in that case, and we would have to go to some other series test to determine whether the series will converge absolutely conditionally or whether it might diverge. And so we begin by looking at that ratio as n goes off to infinity of the absolute value of a sub n plus 1 over a sub n. And what happens in that case, we look at the limit as n goes off to infinity. So we have 9 times n plus 1, all of that raised to the n plus 1 power, divided by n plus 1 factorial. And then for our denominator, we have our nth term, which, if we just go ahead and do the reciprocal for that one, we have an n plus n factorial divided by a 9n raised to the n power. So now we'll just do some algebra and see if we can simplify some things. So we've got the limit as n goes off to infinity. Our 9 to the n will kill off our 9 to the n in the numerator, so we'll just be left with a 9. We've got an n plus 1 to the n plus 1 power. Our n factorial is going to kill off an n factorial in the denominator, so just leaving us with our n plus 1 in that case. So we've got an n plus 1 in our denominator, and then we have our n raised to the n power. So continuing to clean this up, our n plus 1 will cancel with one of our n plus 1's in the numerator. So we're really left with the limit as n goes off to infinity of 9 times our n plus 1 over n raised to the n power. And so here, again, our absolute value bars really aren't doing all of that much, so we can just drop those. So we have our limit as n goes off to infinity. We have our 9, and if we simplify that inside, we have 1 over 1 plus n raised to the n power, which with this, hopefully we recognize the fact that's really one of our definitions for e. So our limit of 1 plus 1 over n raised to the n power just becomes e. And so in this case, our limit is 9e. Well, 9e is going to be bigger than 1, and so the ratio test then concludes that our series diverges in that case. And so here, we've got our second example of using the ratio test to determine if a series is going to converge, diverge, or if our test is inconclusive. So I hope you've enjoyed this, and I'll see you guys in the next example.